Welcome to the MAGO Water Quality Monitoring tool. In this tutorial, we will guide you on how to use this powerful tool to estimate water quality parameters in lakes, reservoirs, and irrigation ponds using Sentinel-2 satellite images. To access the tool, open the tool page on the Sentinel Hub Custom Scripts repository, and in the same web, you can find other free and open source codes to analyze satellite data. You can find the link in the text of this video, or you can just type MAGO Water Quality Script in your web search engine. In the Hub repository, you can see the source code, a description of the tool, and the scientific background, with all sources referenced. You can access the satellite viewer either in the Copernicus browser from the Copernicus Data Space ecosystem or the EO browser from the Sentinel Hub. Both are free web-based applications that allow you to explore and visualize Earth observation satellite imagery and data. A first step when you start using the tool is to locate your area of interest. You can do this either by scrolling in the map or using the search bar. Then you have to select a date with a Sentinel-2 image that is available in the calendar, because otherwise you will just see a red screen. Let's say you are using the Copernicus browser. Once you are in your study area in the Copernicus browser, you can first upload the full source code. The code is shown in the Custom Script Editor section. You will see it in a red box. From the tool code, you can define how you want to process and analyze your data. The code has several variables to perform this configuration. One important variable is the index number. By modifying this value, you can choose which water quality parameter to visualize. You can select from various indicators such as chlorophyll-a concentration, cyanotoxins, turbidity, organic matter, and suspended solids. Each indicator has an unique ID number, allowing you to focus on specific parameters. To adjust the visualization thresholds, you can modify the minimum value and maximum value variables in the script. By changing these values, you can customize the sensitivity of the tool to show in the map low and high concentrations of the selected index. Once you have set up the variables, the tool will generate a visualization based on the selected water quality parameter and the map color you define. You can view the results on the map. For a more detailed analysis, you can access corresponding time series data for selected points or areas. This allows you to observe the changes in water quality over the past few years and conduct in-depth analysis. However, to be able to get the data, you must sign up and log in. It is free and it is easy. Once you do it, you will be able to view the time series plot and export them to CSV. Depending on the time frame you select, you will get the data. If you select for 6 months, 1 month, or longer. Other functionalities allow you to show elevation profile from digital elevation model. You can also get time series for one point and measure distances and areas. Let's look at an interesting feature for image download. You can export georeference images in a few clicks. Another feature allows you to create GIF files with images from time frames that you decide. It is easy to select the period of interest and the images to be included. It is important to note that the tool also filters out non-water pixels in clouds to ensure accurate and reliable results. Let's say you want to study a small reservoir. You have to consider the area that is far from the borders to avoid error, because there is pixel mixing land and water surface. To remove images with clouds in the time series viewer, you just have to move the percentage cloud allowance. With a click, you can export the time series in a CSV format. Also, for water bodies with very strong algal development, the algorithm might recognize them as vegetation, and accordingly dismiss applying the indices there. To force the indices to be applied, you will have to change the index used to discern between water and land. This is done changing the NDWI threshold from 0 to minus 0.25, for example. But be careful, since now the indices are also calculated for areas that are truly land. With the MAGO Water Quality Monitoring tool, you can now proactively manage water quality in surface water. Remember, this is a free software that utilizes the power of satellite technology to make water monitoring easier and more efficient. Thank you for watching this tutorial. We hope you find the MAGO Water Quality Monitoring tool beneficial in your water management endeavors. Remember, for these and other solutions, to visit the project's website, mago-prima.eu.